So here we're continuing to work with functions. This time the focus is looking at creating mathematical models of functions, using some specific parameters in the question. And as it says here, there's no set rules we have to follow. It's more a matter of just looking at some examples. So let's look at some examples. You need to make an open rectangular box, which means we have, as the visual shows, this rectangular prism, but there's no lid, there's no top. An open rectangular box with a volume of 2 cubic meters and a square base as shown. Find a model to express the surface area as a function of the length of the side of the base. And so the x here again represents the distance from here to here. Either of those, it's a square, so it's the same. And so first let's think about surface area. If I want to find the surface area of this object, what do I have here? Well, I have a square base, so I'll say the surface area equals x squared. That's the area of the square base, plus I have these 4 sides. They're all the same. Each of these sides is the same. Each of these sides, the area of it is x times h. So 4x times h, or 4xh. Right, so what I have right now is the surface area of this object, but as a function of x and h, or as a function of the width of the square as well as the height. I want only in terms of x. So I need to find some way to replace that variable there of x and make it in terms of, replace that variable of h and make it in terms of x. So how do I do that? Well, I need to look at something I haven't used yet, which is the fact that this has a volume of 2 cubic meters. So let's think about volume. Volume of a rectangular prism is very simple. It's length times width times height. Or in this case, my length and width are the same, so it's x squared times height. And we know the volume, it's 2, they tell you. So now if I look right here, that h, that height, is the same h I see right there. So this is how I can kind of join these two equations together. And since I'm trying to isolate this equation here and have only the variable x, which means I want to replace this h here with an x, on this volume equation, I want to isolate the h. And so to do that, it's quite quick. Just divide both sides by x squared. So I get h equals 2 over x squared. And so now, using that, I can substitute that 2 over x squared into this surface area function. And so then it becomes this. Surface area equals x squared plus 4 times x times 2 over x squared. And I'm essentially done here. I'll do a little bit of work here to clean it up. But I've now answered the question. I have come up with a function that models surface area as a function of only x. That's it. This expression here on this term here is a little needlessly messy. If I just put it together, especially if I think of it as like 4x over 1, I can say the surface area equals x squared plus, I have eventually 8 over just x, because x and x squared reduce to just a single x in the denominator. And that's a great expression. That's a great equation right here. Sometimes we want to have it as a single rational expression instead of what we have here. Although again, I really was finished right at that step up here. But another optional step is to find a common denominator. Right now that's a 1, so multiply this by x and this by x. And then I have another form of this, in which I have just the denominator of x. And then I have x cubed up here plus 8. So all of these are equivalent, whether it's this, which I like the least, or this one here, before I messed it up, which I like just as much as here. These two are interchangeable to me, but they're all correct. And keep in mind, in a course like this, where we quite often use these functions with technology going forwards, if you're using technology, usually it doesn't care how messy an equation is. So again, everything here is correct. So I really only have one more example on the backside that I break up into 2 parts. And what we have here is an example of a Norman window. It's a rectangle with a semicircle, half a circle on top. And we want to design one which has a perimeter of 30 feet. So we want to show if the width of the window is x. So if I'm calling this x, how can I show that the height, right now I'll just label these with an h. How can I show that the height, that height right there, is equivalent to this in terms of x? So I got some algebraic work to show how this comes together. So first, let's go back to perimeter. Let's think about the perimeter of the shape. And what do I have? I have 4 sides, but one of which is a semicircle, and the other which are lines. And so the perimeter of this, I can express as that x at the bottom plus 2 of these h's plus half the circumference of a circle. The circumference of a circle is pi times diameter, In this case, the diameter of this circle is the exact same as x, so pi times x. But I want just half of it. So pi times x divided by 2. All right, so I want to show that, again, that this h here is equivalent to what is being given to you here. Well, keep in mind that perimeter I have labeled here, I can actually change to 30 because we're told the perimeter is 30 feet. And so now this is just an algebraic question of isolating the h and getting to a form to show that what I gave you here isn't wrong. So the first thing I would do here is isolate the 2h. So I'd bring the x and the the x and the pi x over 2 over, or I'll write it the other way around. I'll put the 2h over here, and I have, so 30 minus x minus pi x over 2. Divide everything by 2. I get h equals 15 minus x over 2 minus pi x over 4, right? Because if you divide a half by 2, you get a quarter. I'm already almost there. To get it into this form that I gave you, I just need to I'm already almost there, as you can see. I just need to find a way to put these two terms together. And so I need to find a common denominator, which is fairly pleasant. Change this to a 4 and change this to 2x. And so I have h equaling 15 minus 2x minus pi x. All of this is now over 4. And I put these together as a single, oh, sorry, that's wrong. Slow down there. I'll do this 2 steps at a time, sorry. Each of these I'll put over 4 for the time being. And now if I look at what I have here, I have a common factor of x that I can take out of each of these. And so if I take that common factor of x out, from the numerators, I have just a 2 left. And then when I take out a factor of x, keep in mind there was a minus here. And I have a minus here. So I'm really, if you look at what I'm writing down right here, that I'm highlighting in yellow, I'm really taking out a factor of minus x. And so when I take out a factor of minus x from here, this becomes positive pi right here. And they have a common denominator 4, so I'll kind of show it like this. Now, if you're a little unsure, because at this point, we probably haven't done a lot of work with taking out negative factors like this, but just notice if you go backwards and distribute it, especially this last term, negative x times pi is negative x pi, so it all matches up. That said, we've now accomplished what we wanted to. We've algebraically shown that h is the same as all of this here. All right, so the last part now is let's determine a function of the area of this whole Norman window as a function of just x. Well, again, first let's think about how do you find the area of this whole shape. I have a rectangle and a semicircle. And so the rectangle is just x times h. That's the area of that part. And the area of the circle is half pi r squared. So let's kind of formalize these things down here a bit. So the area is x times h plus half pi r squared. But I want to adjust a few things about this. I don't want to introduce a new variable here, and which I have done with radius. And if I look back at my diagram, we just realize pretty quickly here, the radius, which is from here to here, let's say, is the exact same as just x divided by 2. So instead of radius, I can say just x over 2. For some reason, I wrote down a pi x over 2. So if I go back to my expression down here, instead of radius, I will write it as pi times x over 2 squared, all cut in half, because remember, it's just half that circle. Now, we're almost actually done at this point. Right now, I want the area is just a function of just x. Right now, I have a function of x and h still. But don't forget that h we see right there, we've already, in the previous step, wrote it as what you see highlighted in blue, which is, again, just in terms of x. So if I want, I can right away just substitute that x with that 15 minus blah, blah, blah. You see up there, and I'm done. Before I do that, though, I would like to clean up this right here. I don't like all these fractions inside fractions, and it's fairly pleasant to kind of clean this up. So let me just leave the xh for a moment. Although, again, it is optional. But pi over 2 times itself is, sorry, I keep saying pi. X over 2 times itself is x squared over 4. And then all of that still being divided by 2. And if you take a quarter of something and divide it by 2, you end up getting the same as just dividing by 8. And so everything you see here is the same as xh plus pi x squared over 8, which, again, I personally like better than what I see up there. It's easier to work with, and even if we're doing this and using technology in some way, it's easier to type in. All I'm going to do now is really the most important part, which is take this h, I'll do in the last step, and replace it with what we were given in this previous step. And then I could clean it up, but I'm definitely too lazy to. And so the area is going to be x times 15 minus what we were given in the first place. Plus what I had before. And there's definitely ways we could simplify this expression here. In a course like this, though, where the point is less to just do a whole bunch of algebraic work and more try to use technology to apply this, this is, if we had to use this in a graphing program or something, this wouldn't be hard to type in. So I'm just going to leave it like that, because I now have the area of this Norman window, and if you look, the only variable I have here is an x. There's no other variables. So I'm done.